So let's start. So this talk, Qt and C++20, it was already presented at last year Qt Summit. It's basically about status of C++20 implementation in Qt. And the author of this talk is Marc, Mutz, who couldn't be here because he chose to go on holidays, and I cannot blame him for that. And he asked me to be a speaker, and that's why I'm standing here in front of everybody. So I will do my best to present his insight and his thoughts about the status of C++20 and Qt. Disclaimer. I mean, disclaimers are never important, so you can skip this. The most important part is this is not talk about C++20. We will not focus or go in details about every single feature because C++20 is a huge monstrosity, and you can have like 5 one-hour talks just about the coroutines, and you still won't be able to use them. So we will just focus on the Qt in the context of C++20. This is the agenda. First, we will talk briefly what is C++20, what it brings to the table. The second chapter is what has to do with the Qt. What obligation on us as an author's library we have when the standard progresses and introduces new things. Then the constraints of the Qt. Because like we are constrained by the internal factors like the API compatibility, and by the external one like the compilers availability, the toolchain support for the features. And then we will go to the chapter 4, which is going through each feature, not each feature, but going through many features of C++20 and see how they can influence the way we write software in Qt and how they can influence the way that the user will use the Qt. So what is C++20? Obviously, it is the 6th standard, it follows C++17, C++23. But what is most important is that it is a major release, just like C++11 was. So it's not just a syntactic sugar, it's just not some minor library features, but it fundamentally changed. We write the code and we think about the code, even the way we compile the code with like modules and everything. So C++11 was a revolution. It started a new era, which we called a modern C++. Although it was 12 years ago, and we still call it modern. It just tells a lot about C++ community. What it thinks about modern definition. C++11 brought the move semantics, the lambdas, the const expression, and Björn Strusop said that it feels like a new language. And now C++20, not now, but because it's from 3 years ago, but C++20 also brings a lot of new stuff which fundamentally changed the way we write C++. Modules, which are a huge change, not only language, but also the build model, the compile time string vector, concept ranges, and many, many more. So what does this got to do with Qt? So Qt is still implemented in C++, and we are not planning to rewrite in Rust, like a lot of people are asking. And I know that previous year, 2022, was the year of like C++ successor languages. We had the CPP front at CPCon. We have Rust, of course, in the background. We had the Google thing, Carbon. We have the Ziglang. We have the Circle compiler. So there's a lot of discussion where the C++ is going to, what is the future of the language, and those are all very positive, in my opinion, directions of the development. But Qt is written in C++, and it will be in the foreseeable future, and it's not going to change. So we need to follow the changes to the language. And C++20 introduces new feature, it deprecates old feature, it removes feature. So we need to take care of it. And a lot of users want to use C++20 in their project, naturally, because the modern standard usually makes the writing in C++ way easier and simpler, at least more exciting. And for us as author libraries, we need to make sure that Qt itself compiles the new standard C++20, preferably without warnings. And then the user code also compiles without any warnings when it uses Qt. Those warnings could be caused by some Qt API use or Qt headers, etc. So there is no way around it that Qt really requires C++20 at some point. That's definite. because the C++20 will be default at some point. It will be default C++ mode for the compilers. It will be what the industry is using. So we are not standing in the decision if we use C++20 or do we not use it, but rather when do we use it and how do we incorporate C++20 in our code base. And we are also developers and we want to use the new features, those new shiny features that we've been waiting years for. And the dependency of Qt on specific C++ version is nothing new. Qt 5 was depending, it could use any C++ compiler, even no STL, before Qt 5, sorry. Starting for Qt 5, it was depending on C++ 98 and working STL standard library. Qt 5.7 is requiring C++ 11, the modern C++, and current version of Qt 6 is requiring C++ 17. There are some workarounds usually, but generally it works. So why should you care as a Qt user? This is C++ meetup, so I guess that everyone cares about C++. But if you are just a Qt user and you use QML only or Python, then you don't really need to care. Maybe you will see some side effects improvements when we optimize some stuff using more views or ranges. We don't do copies and we reduce number of allocations. But if you are interested in C++, then you obviously are. This talk is for you.
What's NOI?
Huh?
What's NOI?
NOI is non-owning interface, and this sort of Pandora that I don't want to open. Maybe I will. So what does constrain Qt? Why we cannot jump straight to the new version of C++? So there are some binary compatibility issues, there are source compatibility issues, and there are some toolchain availability issues. So binary compatibility constraints with this ABI. So we have those constraints that we put on ourselves that app compiled older Qt must also run against new Qt. So when the user links with Qt, they can just link with new version and nothing breaks. And with given patch release, the app compiled against newer Qt must also run against olders. For example, if you run on 6.5.2, then it should also work with 6.5.1 or O. So we cannot remove symbols, we cannot add any symbols in terms of like ABI stability. And without requiring C++20, we cannot use C++20 types in our ABI, which is pretty obvious. Then there are source compatibility constraints, which are a little bit more relaxed. And that means that this is about the compiling the source. So the app developed against older Qt must compile against newer Qt. So we cannot remove the functions or type from our API, because that would break it. Now, this weird Q6 category A, if you Google it, you will go to the Qt documentation page, and it shows some breaks which are permissible, because they will break the compilation, but it's easy to fix by a user without checking for which Qt version it targets. So for example, like deprecating a function, removing some include from our header, so then the user can just add include in their headers. So there are some permissible source compatibility breaks, but they are not serious. And we have this mechanism, which is very important, Qt removed scenes. And that basically means that our API and ABI can vary. We are not binding API to API. For example, some function can be in API, can be just in API, or can be in both. And that is a very important tool for us. So we can add any functionality. Because previously, when we wanted to add new functionality, we were adding the overload of the function. And you cannot add overloads in infinity. Sometimes there will be some conflicts, some ambiguous calls. And now we can keep the function in the ABI, so we don't break it, but we can remove it from the API. So there's no more ambiguity when you call the API. And we have also added the configure switch, disable deprecated up to, so you can clean some, even though we are targeting only from 6.2 upward, you can just clean all the ABI that was before 6.2 if you don't need that backward compatibility. And the last factor is something that we don't control. It's toolchain availability, so the compilers build tools. And this is not nothing new, like even now in C++17 we have some workarounds. For example, Qt 5.15 still has some MSVC and STD atomic workarounds. And we expect something similar to be C++20. So when we want to do something new from C++20, we have two options. We can either the feature is supported through entire toolchain, or we need to backport it. So we either use the lowest common denominator of the entire toolchain that we use, and the Qt is cross-platform, so there's a lot of tools, or we have our internal backport mechanism. So how does it work? How does backport mechanism works? So in the past we had some bad experience with it because, for example, we added a QsConst in Qt 5 and it still remained until Qt 6. It's part of public API, so it's hard to remove, it's hard to deprecate. Some people rely on it. So the new mechanism, which is on the right side, is called Q at n, which basically means we have a separate namespace for n version of C++. So for C++20, it will be Q20 namespace. And then we put the QSpan or whatever, or Q or coroutines, whatever we need inside the namespace. And in our internal implementation, we use the STD on the platforms that we can. So they support the standard features. And on the platforms they don't support, we use some internal implementation. And the idea is that when you need to bump the version of C++, then you can just change the Q20 to STD, and it will work like a charm. So this is supposed to be easier in migration, and this is the backport mechanism that we will try to use for C++20. So what do C++20 features mean for Qt? There are a lot of features: module, concept, coroutines, comparison, and we'll go through all of them briefly. So slide format, on the left side there will be what the feature is about, and on the right side it will be what is the context of the feature, what is the meaning of the feature in a Qt context. So modules. This is the feature that a lot of people were waiting for, and for a reason, because it's a great improvement. It's supposed to fix the insanity caused by header files. The build should be faster. It guarantees the ODR compliance by design, because each module is compiled only once. The order of import doesn't matter. The imports are not transitive, so if you import one module, you don't import everything that that module uses. So we would really like to use it, but we cannot because of macros. And macros cannot escape modules, so macros defined in the module cannot be exported outside of the module. And the thing is that Qt uses a lot of macros. It uses a lot of macros since the very beginning: the signals and float, the Qt object, the Qt property. So there's no really easy way for us to use the modules in Qt. There may be some ways when we modularize some stuff and then we put all the macros in one header, but this requires a lot of experimentation. So don't expect modules in Qt anytime soon. Concepts. Concepts are the named type requirements for template time parameters. And this is very interesting, I think. It not only makes the code easier, the templates easier to parse, easier to read, it also makes the error messages by compiler much easier to parse for a human. And this is something that we can indefinitely use. The concepts are not something new in C++, because it was used in the documentation. We have these concepts of like movable or copyable. So it was in the documentation, and now it just makes the way into the language, so you can enforce it in the language. This is something that we can use. For example, in the test, we can check with static assert that Mutz is lockable, that it follows the concept lockable. So it will have impact on our code. It will also have impact on our documentation, because C++ documentation was written that way before, using concept. The Qt documentation wasn't, but this is something that we can change, because we want to use the language that is more familiar, that developers are most familiar with. And if the language of concept will be so popular in STL, so the C++ people will get used to it, then we will also try to use it in our documentation. It's easier to say that this object or this class must be movable. Let's say this must have a move constructor, blah, 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 blah. So it's just also documentation tool. Coroutines. Coroutines are functions that can be paused and then resumed later. There are like two types, stackful and stackless, and C++ implement stackless coroutines, which means that they are not storing entire stack on the heap, because when the coroutine pauses, it saves an entire context and the information on the heap. It can be optimized under some condition, etc. But basically, there are like functions that can be paused at some point and then resumed later. And what it means for the Qt. We have some obvious candidates to make them awaitable. For example, Qfilter, timers, Qsignal. Noise stands for non-only interface, and then the coroutines can also take some place for returning lazy sequences, because then if you return lazy sequence, you don't bind the user to the specific implementation of your containers, of your data structures. Well, the problem with coroutines in C++20 is that C++20 doesn't give us coroutines out of the box. It gives us tools to build our own coroutines. And all the stuff that you think about coroutines, like generator and some other stuff, is currently with the third-party libraries, like stdcoro, or the generator will be implemented in C++23. So it's not something that we can use out of the box. And executors didn't even make it into C++23, so maybe they will be in C++26. So what we can do, maybe we can implement something like QGenerator if it's worth. There's still discussion ongoing, I think, and maybe in the future, when the executors go into the language, we can maybe Q event loop as executor. There's some research required, and today we will have another talk about coroutines and in Qt in more details by Morten, so I don't want to exploit the topic, and I don't know more about it anyway, so let's move on. Spaceship operator. So Qt has a lot of relation operators, and spaceship operators really make it easier to define relation operators. We have some problem with qvariant because qvariant had traditionally relation operators, but it doesn't really make sense to compare two qvariants which have like different types. Like one qvariant contains a std string, the other contains like an int or some object. It doesn't make any sense to compare them to each other. And what the spaceship operator or the three-way comparison operator offers is that it doesn't return -1, 0, 1, but it returns like partial ordering, weak ordering, and strong ordering information. So it gives some feedback about the strength of this relation. So for example, partial ordering means that some values may be unorderable. And this would be something that we could use in the qvariant. So when you have two qvariants and each of them contains the same type, then it makes sense to compare them. But if they contain a different type, then there's no point. So in that case, we could actually bring back relation operator for a qvariant and use the partial ordering, which will allow unordered values. There's a lot of discussion going on where we can implement it, but I think that this is something we will use quite extensively in our internal implementation. So in C++20, to get all of the relation operator in comparisons, you only need to define two operators. Equality operators, and this will generate equality and inequality for both sides. Doesn't matter the order. And then the spaceship operator, which will generate 8 comparison operators. So there's something very handy, so the code will be more compact. And Qt uses a lot of relation operators, so we'll definitely use this. The other use of spaceship operator may be for NTTP, which is non-type template parameters. Because for the non-type template parameters, there must be structural types required by the language, and they must have defaulted relation operators. And now it's super easy to do it with the spaceship operator, because you just need to define the spaceship operator and the equality operator, and they can be defaulted, and then you have all of the relation operators defaulted. So it's easier to make your type structural. And we have some obvious candidates for it. For example, qflags, which is just a wrapper around enum, and enums can be templated, obviously. We have some qfloat, which is just a wrapper around float. And float numbers can be templated as well since C++20 actually. So we could use this to allow more of our types to be used in the NTTP. Consint. So this keyword makes sure that the initialization of variable is done during compilation. And this is something that we will use not in our API, but internally, to make sure that something that we think is initialized during compilation is actually initialized during compilation. This is quite important for library authors, because when the library is loaded into the program, then all of the static objects are initialized. So we want to make sure that we are initialized as much as we can in the compile time instead of the runtime. And there's nothing that the user really can do about it if we make some mistake and initialize something in runtime instead of compile time. So this will have a huge, not huge improvement, but it will have impact of every single application of Qt, which uses Qt. We have shipped in 6.5, 6.4 qconst init, which is our internal wrapper around const init. The client is already supporting these features with the compiler attribute. So if you are using client in C++17 in Qt, then we are already getting this behavior. And we already fixed a couple of bugs that we thought that, oh, this is being initialized in the compile time, but it wasn't, so it's quite a handy feature. Const eval and const eval are like immediate function, so those are like const exp function on steroids that they can be only called during the compile time. And this is quite a nice feature, but it's lacking one mechanism. If const eval, it would be really nice if being inside the const exp function, we can know what is the context we are being evaluated in. Are we being called in the compile time or runtime? And the if const eval is coming in C++23. So I think we will not use const eval much now, but in C++23, I expect it to get quite a lot of use in the Qt code base. So const exp addition. Now in the C++20, you can actually use a const exp std string and vector, so you can have a compile time, a heap allocation. So it is quite nice. So you can have dynamic memory allocation in the compile time. And we have some classes that would benefit it. For example, version number or varlen array. We cannot do it for the qstring because, for example, qstring has some atomic operation. Atomic operations are not allowed in the context. But we could use it for the qvarlen array, which has some short buffer optimization, I believe. So sometimes it may allocate on the heap, sometimes it doesn't. So we could, this is the feature we can definitely use to move a lot of, not a lot, but some allocations to the compile time. Now span. Span is a generic view over a contiguous data, and it can be read-only, it can be mutable. So it can be also used as an output buffer that you write into it. And I think we can really have a good use of it in the non-only interface context, because you can return the span or take the span, and we can reduce some number of allocations if we just think clever enough about the ownership. So that's something that we could use, and we are planning to have a QSpan in the 6.6 because we think it could have some impact on the performance. And this is not only, this is just a view. But it can be read-only and can be mutable. Feature test macros. So those are macros that you can use to detect if the compiler is supporting given feature of a language, like C++20 feature if I have optional or any feature you want. And this works well if you don't know what compiler we are on, or if you just want to have some experimental feature that will be in C++23. And you can use the feature test macros to test for it. And the C++20 mandates the SD6 feature test macros. And SD6 feature test macros are macros that were sort of recommended by the C++ committee, but they were never part of the standard. And they are part of the standard now. They have been already implemented by a couple of compilers, apart from MSVC, as I remember. Yes, and now C++20 forced them to do it, so now MSVC will have those macros even for the C++17 builds. So you can use a syntax like this to detect if a given feature is supported by your compiler. And there's one big improvement, because previously there was a problem with GCC, I think, that if you want to check if, for example, optional is supported in your container, then you need to first include the optional header. But you don't know if it existed, so you need to check if the optional header existed. You need to include it, and you need to check the macro. And sometimes the GCC was saying that the header is there, but when you try to include it, it said, but we are on the wrong version, we cannot include it. So you need to have another test to say, okay, am I in the C++ 14, so there is optional. Then if there is optional, can I include it, and then check this. And what C++ 20 changes is that all of those macros will be just in one header, which is version. And this makes it very easy to test for the features. You just include the version header, and you don't need to worry about all that if, def stuff. And the availability of this feature in the compilers is pretty well supported. I think it's only Integrity that doesn't support it now for Apple or something. But MSVC supported it, VCC, Clang. So this may be actually the first C++ feature that Qt will require. Ranges. So ranges are just a fancy abstraction over iterators. And they will change a little bit the way we use the algorithms from STL. And the Qt containers are already ranges, like QList is already a range. You can already use it as a range. And then there's a range and a view, and view is non-owning. And for our classes to be a view, we need to opt in by some template specialization, if I remember correctly. So this is the work we need to do. So our classes, containers are already ranges, but we need to make some work to enable the views. There's some discussions whenever copy on write is how copy on write continues through the view. Standard does allow it, but it's sort of conceptually misleading because the views should be non-owning and copy on write containers are owning. So we need to just have a little bit more discussion internally and see what we come up with. Chrono. So Chrono was introduced in C++ 11, then some user-defined literals was added in C++ 14, and we never really used that much Chrono in Qt. We have our own stuff, like int milliseconds traditionally, or Qt deadline timer, which they have their own problems. For example, any timer suggests it's only for the time point by the name, but it also can store durations. And the deadline timer stores, I think, time in nanoseconds, but most of our APIs use milliseconds or seconds, so there's some unit mismatch, so this is not perfect. So we would like to use a little bit more Chrono. And in C++ 20, added the time zone support, and non-Gregorian calendars, etc. And we already have the Q time zone and Q calendar. And it's not ideal if we are duplicating what is already in the standard. So I think partial interoperability between STD, calendar, and time zone is, I think, already shipped in 6.4. And I think our intention is that when we move to C++ 20, we will rebase the current implementation of Q time zone and Q calendar to actually use the STD chrono and to make it fully interoperable, so it's easier for users to use it and pass the types around. And format. So format is a way to format your classes, your types, your objects in a very Pythonic way. It's similar to printf in a way, because you can, the order of the arguments doesn't matter. It's easier for the translators to translate stuff, and it's more familiar to people coming from different languages. It's also extensible to the user types like the IO streams. And what we like to do, we would like to definitely support it. You have types like qstring, which have equivalent in STD. So for the types that have equivalence in STD, we want the format to behave like the formatter in STD. We have this similar option and equivalent behavior. And for the types that we don't have anything similar in STD, we need to figure out some options and what is the best API for users to use. And then once we have the formatters for our types, we can try to unify the way we format our objects. Because currently, for example, there can be separate logic in qdebug, qtestlib, Q-string arc, and it's far from perfect. So having one universal format mechanism can be a very good way for us to simplify our code and make the behavior more consistent. So what is the adoption of C++20? So I think this is the current plan, that there will be 2 steps of adoption of C++20 in Qt. So Qt 6.9 will require C++20 for building Qt. So we will use C++20 in the Qt, but we will not expose it in the API. And Qt 6.12 will require users of Qt to build with C++20. So starting with Qt 6.12, we will expose it to the API. Those are just the plans. This is not the official roadmap. This is not binding. So if it doesn't happen, don't blame me. But I think those are the plans. And there's also issue of binary compatibility. Is the first option even possible? Can we build Qt with C++20 using the new standard library? And then can the user link their codes using C++17, which has different standard library, how the ABI will work, how we can make it work. So yeah, this is something we will consider. And we need to test if it's possible. There are some key takeaways that modularization is far away. Then we are committed to C++20 compatibility. We will have more consistent behavior with relation operators because the three-way comparison operator simplifies a lot. We will try to support format chrono and ranges internally. And we have this mechanism for backporting, so this QNN namespace. So this will be Q20 namespace in this case. Yeah, any questions? Good. Perfect. Perfect. I only work here less than 3 months, so I'm very happy you have no questions. Those are some references for the abbreviation. Thank you.